This video will explain how to read the electrical boards on the Bale Band-it. The Bale Band-it has two onboard computers, one in the front relay box, located at the front right corner of the machine, and one in the band relay box, located inside the band box on top of the machine. The electrical relay board for each computer has a series of 14 inputs and 14 outputs. The 14 red LEDs correspond to the 14 inputs. When a red LED is on, it means that the corresponding input is receiving a signal. The 14 green LEDs correspond to the 14 outputs. When a green LED is on, it means the corresponding output is being given power. Let's take a look at some very useful diagrams that are found in the operator's manual. This is the diagram for the front relay box and can also be found on the inside of the box's lid. On the bottom left are the 14 outputs, and on the top right are the 14 inputs. Each input and output is labeled to indicate its function. Each wire is labeled with the input or output number that it should be plugged into. This is the diagram for the band relay box and can also be found on the inside of its lid. On the bottom left are the 14 inputs, and on the top right are the 14 outputs. Note that not all inputs and outputs are used. Here is a video clip of the front relay box as the machine is operating at top speed. There's a lot happening there, so let me pause it and walk you through it. Let's start with the red lights. You can see that red lights number 4, 7, 11, 12, and 13 are all on. This means that those inputs are receiving signal. Let's look at the front relay box diagram again. Here we see that input 4 is the horizontal plunger reed switch. Since it is on, we know that either the front or back set of magnets on the horizontal plunger are in line with the reed switch. Since input 7 is on, we know that the kicker is either waiting to kick a bale over or it has just finished kicking one over, because one of its two magnets is in line with the reed switch. Input 11 is on, which corresponds to photo 2 sensor, but notice that the diagram says photo 1, 2, and 3 sensor inputs are normally on. That means that these inputs stay on until a bale passes in front of the sensor, and then they turn off. Since photo 2 is on, we know that there is not a bale currently in the vertical elevator. The same is true for input 12, which is the photo 3 sensor. Since the input is on, we know that there is not a bale currently on the vertical plunger platform. Notice, however, that input 10 is not on. That means there is a bale in front of one of the three photo 1 sensors. Lastly, red light number 13 is also on. As the diagram indicates, this input comes from the e-stop button, which is located next to the vertical plunger. When the e-stop button is pulled out, this light is on, and the machine operates normally. When the e-stop button is pushed in, this input light turns off, and the hydraulic safety valve closes, which stops the motion of the machine's components. Now let's move on to the green output lights. We can see that 1, 3, 5, 10, 11, and 12 are all on, which means those outputs are receiving electrical power to perform a task. From the diagram, we see that number 1 is the kicker solenoid. But from this diagram alone, we don't know what the kicker is being told to do. Conveniently, there is another set of diagrams to help with that. This diagram summarizes the valve functions on the front hydraulic manifold. The background is the top view of the manifold. The numbers on the solenoids correspond to the output numbers on the front relay board. The arrows in the associated pictures indicate the energized state of the solenoid coils. This will make more sense as we continue the example. Note that there is a similar diagram for the banding box manifold and the outside banding box manifold. Now, back to the green output lights. We know that number 1 is on. On the front manifold diagram, notice the solenoid labeled number 1. This means there is a wire running from output 1 to this solenoid. From its associated picture, we can see that it does control the kicker. The curved arrow tells us that since output 1 is on and is energizing solenoid 1, then the kicker is in the kicked position or is on its way there. Green output light number 3 is also on. On the manifold diagram, we find the number 3 solenoid and look at its picture. This solenoid causes the vertical plunger to move downward. So either it is moving down now, or it has already moved down and is being held in that position. Output number 5 controls the strap guide arm motor. Notice that solenoids 5 and 6 perform opposite tasks. If output 5 is on, the strap guide arms move down. If output 6 is on, they move up. If neither is on, the strap guide arms stop. Since output 5 is currently on, we know the strap guide arms are going down. The last 3 green lights that are on are 10, 11, and 12. Output 10 controls the vertical elevator. Like 5 and 6, solenoids 8 and 10 make the motor turn in opposite directions. Since output 10 is on, we know the vertical elevator is currently running in the upward direction. Output 11 is special. The diagram says it controls the hydraulic shutoff valve and light and horn. Do you remember input 13, which tells whether the emergency stop button is pushed? That input receives its power from output 11, as shown in this electrical diagram. This output should always be on, regardless of the status of the e-stop button or the safety valve. If the Band-it loses electrical power or the emergency stop button on the iPad is pushed, output 11 will turn off and the safety valve will close and the Bale Band-it will not operate. Output 12 is simpler. It controls the horizontal elevator, which only moves one direction. Since the light is on, the horizontal elevator is running. That concludes this example. Though I did not cover all the inputs and outputs, this should give you a good understanding of how to identify what signals the relay boards are receiving and what operations the machine is trying to perform. If the Bale Band-it stops and displays an error on the monitor or app, the lights on the relay board can be very useful for diagnosing the problem. Refer to the operator's manual for more information.